So suppose y equals c of x gives the cost function to manufacture x items. This is the way we've been thinking about this in previous sections, so there's nothing new. The average cost per item is found by dividing the cost function c of x by x. And we denote it by c with a bar over it. Sometimes I'll say average cost, sometimes I'll just say c bar. But here it is, our cost function divided by x. The average revenue per item or the average profit per item could be defined in the same way. We could have an R bar, which would equal R of x divided by x, or a P bar, which would be average profit, and that would be P of x divided by x. But here we're going to just work with average cost because that's the thing that you usually work with in business. You want to minimize that average cost as much as possible in your business. So suppose that the cost in thousands of dollars for a company is given by C of x equals the quotient 2x squared plus 4 divided by the quantity x plus 1. And that's to produce x items. The first thing we want to do is go ahead and find that average cost function. So I'll write out my average cost function equals C of x divided by x. But to make things a little bit easier to work with here, I'm going to think of that as C of x times 1 over x, which really doesn't make any difference. It's exactly the same thing, because if you were to multiply these together, you'd think of that C of x as being over 1, and you'd multiply top times top and the bottom times the bottom, or the 1 over x. This is just going to make it easier for me to work with. So now let's put in our cost function. So now we get the quotient, 2x squared plus 4 on top, x plus 1 on the bottom, times 1 over x. And now that's my average cost function right there. So in the next step, now we're going to talk about the marginal average cost. The marginal average cost is just the derivative of the average cost function. And that shouldn't be a really big surprise to you, because whenever we've used that term marginal, it had to do with instantaneous rate of change, which means we'd need to take some derivatives. So what would be the marginal average cost function for the previous average cost function? Our C bar of x equals 2x squared plus 4 divided by x squared plus x. So I've gone ahead and written this down, and I'm going to recognize right away that that's a quotient, so we're going to have to apply our quotient rule. So let's match up what u of x and v of x should be. So u of x is always the top part, v of x is always the bottom part. So now let's just go ahead and apply the quotient rule. C bar prime, which would be the average cost, the prime means that we're doing marginal, is v u prime minus u v prime, our VUV, over v squared. Remember, it's a subtraction in that VUV. Now we'll go ahead and put in our values. So the v was x squared plus x. U prime is just the derivative of the top part, and the derivative of that top part, 2x squared, will give us 4x. Derivative of 4 will be 0, so that's just 4x, minus u, 2x squared plus 4, times the derivative of v, so the derivative of x squared plus x is going to be 2x plus 1, so I'll go ahead and put that in place of v prime, and on the bottom we have v squared. So we've done the derivative here. That's our marginal average cost function, but I want to demonstrate a little bit how we can simplify these things. Mostly what we're going to be doing here is we're going to be simplifying the numerator. So what I need to do is I need to multiply out each one of these terms here. So I'll go ahead and multiply the 4x times x squared, the 4x times x, that gives me 4x cubed, plus 4x squared. I need to FOIL out 2x squared plus 4 times 2x plus 1, but at the same time I need to distribute that negative. So first times first, 2x squared times 2x will give me 4x cubed, which I need to subtract. My outside term is going to be 2x squared plus 1, which I need to subtract. My inside term will be 4 times 2x, which I need to subtract, so that's 8x. And then last times last, 4 times 1, when I subtract that, I get subtract 4. Now what I'll notice is I have a lot of terms here that I can combine together. I have 4x cubed minus 4x cubed. I have some squared terms. I have a linear term with x in it, and constants. So let me combine those together. So when I do the 4x cubed minus 4x cubed, that goes away. 4x squared minus 2x squared gives me 2x squared. The minus 8x and the minus 4 just come along for the ride. When we use this later on, we're going to be wanting to minimize the average cost. And so what we'll be doing is we'll be taking this function and setting it equal to 0. Because the minimum for the average cost function will occur where the slope of the average cost function is 0, and this function, besides being marginal average cost, it's also the slope of the average cost. So we'll be setting this equal to 0, and where it's going to be equal to 0 is where the top is 0.